All right, number 7. This time we're going to use the standard form of the equation. We're going to find the vertex, the intercepts, sketch it, find the axis of symmetry, minimum, maximum value, domain, and range. Okay, so a lot of this stuff we can do with not much difficulty. We're not going to change it to vertex form. We're just going to use the formula. So we have 5x squared minus 15x plus 4. All right, so we're going to start out with the vertex. So x equals negative b divided by 2a. That's going to be opposite of negative 15, which will give me a positive 15. And then 2 times a, which will be 2 times 5. So we have 15 divided by 5, which is 15 over 10. And we'll just have to reduce that. It won't be a whole number. 15 over 10 will reduce to 3 halves. All right, so since it's not a whole number, it will be a little bit more messy when we're trying to do synthetic, but I'll do it and then we'll double check by plugging it in. So I'm going to do 3 over 2, and then my coefficients are 5, negative 15, and 4. And we'll just double check when we finish. All right, so what happens when you're doing a fraction? You're going to multiply by the top number, divide by the bottom. So this will be 3 times 5 is 15. 15 divided by 2. So I have a 15 over 2 here. So 15 over 1. To get a common denominator, I will have to multiply top and bottom by 2. So this is the same as a negative 30 over 2. And then I can do the math. So subtract the 30 and 15, that will give me a negative 15 over 2. And then I'll repeat. So 3 times the top, which will give me a negative 45. 2 times the bottom will give me 4. So negative 45 over 4. Now this is 4 over 1. So I need a denominator of 4. So multiply top and bottom by 4. This is the same as 16 divided by 4. Now if I subtract, because they're different signs, this will give me negative 29 over 4. Okay, so this is what I'm saying the y coordinate is, negative 29 over 4. Plugging this in, I would do 5, and then 3 over 2 would get squared, and this is the messy part of plugging it in as well. 15 times 3 over 2. Plus 4. So I'm going to let the calculator do the squaring with the fractions and everything. We could do it, it just takes a little bit of time. And we'll do 5 is 3 divided by 2. Let me actually clear this. I wanted to put it in fraction form, so I'm going to do 5 and then alpha y equal enter. And then we'll do 3 divided by 2. So doing it this way, it will go ahead and put it in fraction form for me, since I'm entering it that way. Minus 15 and another 3 over 2. And then plus 4. Enter, and we get negative 29 over 4, so it does work out. So now we have our vertex. 3 over 2 and negative 29 over 4. This gives me a lot of information, okay? Parabola positive, so it opens up. We have a minimum. Because I know I have a minimum, my domain or my range is going to be from low point to high point. So I can go ahead and say my domain and range. Domain is all real. all real, as long as we don't have any restrictions. Range will go from the y value, negative 29 over 4 to infinity. We want the x and y intercept. X intercept, that means we're going to make y equals 0. So we would have to see if this factors. Plug a 0 in. 5x squared minus 15x plus 4. If we do 5 times 4, that gives me 20. Factors of 20 we want to add to get 15. I don't know if we can find any. 1 and 20, 2 and 10, 4 and 5. So it won't factor. This means we'll have to do quadratic formula. So to get my x-intercepts, I have to do negative b plus or minus square root of b squared minus 4ac all over 2 times a. Okay. Over here, I will go ahead and do the y-intercept. That one won't be bad. Which means x is 0. So whenever you have this function and you plug a 0 for x, this term zeroes out. Minus 15 times 0. So zeroes out plus 4. So you just get 4. Y equals 4. So you have a ordered pair 0, 4. Y-intercept is fine. X-intercept, got to do quadratic formula. So I'm going to plug everything in and I'm going to let the calculator do the heavy lifting. So opposite of b, negative negative is a positive. So we get positive 15 plus or minus square root. Negative 15 squared minus 4 times a, which is 5, times c, which is 4, all over 2 times 5. I'm just going to put a 10 down here. So 16 times 5 is 80. I can do most of this. Math is not too bad. So 15 squared to 25. This will be minus 80. All over 10, and then we subtract 80, so that will give us 145. So we're looking at 15 plus or minus the square root of 145 divided by 10. Can this reduce this radical square root of 145 divided by 5? Twice 29, it won't reduce. So our two x-intercepts, we'll leave it in this form. We'll have 15 plus square root of 145 over 10 comma 0 and 15 minus the square root of 145 over 10 comma 0. Okay, provided no errors were made. So let's just double check to be safe. I'm only going to plug in this part that's under the square root. And we get 145. Okay, so looks good. All right, we can start entering everything. The parabola opens upward because it's positive. The vertex 3 over 2 and negative 29 over 4. X-intercepts. They won't let me do a plus or minus. I'll do the fraction first. 15 plus square root 145 over y-intercept, that was nice. We got 0, 4. Sketch it. We're gonna plot these points. It's gonna be hard. I guess it'll still work out. We'll just be able to type everything just like we need to. So first point, I'm gonna do the x-intercept. So the 15 plus, I wonder will it allow me to do not approximate. For example, write 1/3 and not 0.33. I could enter and find some other values. The easiest thing to do, because I don't have a square root right here. Let me see. And I don't want to go through worrying about typesetting. Easiest thing to do to find some other points would be to go either side of your vertex form. So once you find the x-coordinate of your vertex, which is 3/2, we want to do something either side of it. So this is 1.5. So I can plug in, well, we can't do 0. We've already done 0. We can do +2 and maybe a -1. And so I'll do +2 and -1. I'll just plug those two in. +2. I'm going to do it with synthetic division and work it out. +2, plugging it in. 5, -15, and 4 with a +2. Bring down to 5. 2 times 5 is 10. Do the math. We get -5. 2 times 5, -10. We get a -6. Okay. So we get order pair 2, -6. That's one point I can use. And I'll do the same thing with -1. That's going to be my half box number. So 5, -15, and 4. Bring down the 5. -1 and 5, -5. Add, we get -20. -1 and -20 give me a +20. Gives me 24. So another order pair would be -1 and 24. Okay, so I'll use those 2 points in addition to my vertex. I'm sorry. Couldn't see all of that, and I realized. So 2, -6. Add a point. 0, 4. Add a point. Really, I think all you need is 2. 2 of them it'll work. But just, oh, that's a y-intercept. That's not even my vertex. I need to put my vertex on here. My vertex, I'm sorry, was the 3/2. I definitely want that point on there for sure. And -29 divided by 4. I don't need the other one. I can add it. It won't change anything. If I add the other point we found, -1 and 24. Okay. So we have all those points on there. We're going to draw the parabola, place it on this vertex. It opens up, and kind of see it goes through all of those points that we have. Axis of symmetry, the x-coordinate, x equals negative, not negative, just 3 divided by 2. Don't need the negative. And the function n has a minimum. The value of the minimum, -29 divided by 4. And domain, all real, negative infinity to positive infinity. And the range, we have negative 29 divided by 4 up to infinity. All right, and that should be it.